There are trillions of dollars worth of riches hidden among the rocks and dust of our solar system, enough to make every person on Earth a millionaire many times over, and it's closer than you think. It's up there floating around us right now. So if we know about these vast natural resources, why aren't we up there grabbing them already? Today we're answering an enormous cosmic question. Why are we mining asteroids? Let's get started. The search for gold has driven humanity to do some pretty crazy things, from enduring deadly drops to jumping into raging rivers to fighting wars and killing people. But the discovery of gold on the moon, Mars, or hurtling through space might just be the most exciting yet. You see, even though the moon landings happened more than 50 years ago, our reach beyond Earth doesn't really extend very far. Most deep space missions have been either flybys or orbiters that can't land on or take off from other worlds due to limits in their fuel supply. They need to launch with all the energy they'll use for months or even years from their landing and take off again, which means rockets have to be huge, expensive, and not reusable. But there is a solution. We can fuel rockets, build habitats, and set up shop in space by harvesting resources found in asteroids. Asteroids are rocky remnants left over from the formation of our solar system about 4.6 billion years ago. And there are millions of them orbiting the Sun between Mars and Jupiter. This region, called the asteroid belt, contains more than 2 million space rocks larger than 1 mile across and trillions more smaller ones. So we won't run out anytime soon. Asteroids also come in a variety of flavors: stony, metallic, even carbon-rich. And each one is unique with its own chemical composition, spin, and gravitational pull. And that means we could pick and choose which ones we mine based on what we need, sort of like picking your Starbucks add-ons. So, how much stuff is actually in these space rocks? Well, the asteroid psyche is made almost entirely of iron and nickel. It's so dense and heavy that scientists believe it's the exposed core of a protoplanet that never quite formed. Meanwhile, carbonaceous chondrite meteorites contain organic compounds and are the most likely source of the material that gave early Earth its water. Even stony asteroids like Vesta and Pallas have more than 10 times the amount of rare earth metals as Earth's crust. And rare earth metals are super important because they are used in everything from advanced alloys to smartphone components to solar panels to nuclear fusion magnets. Plus, nearly every asteroid is packed with water ice, and water can be split into hydrogen and oxygen, both of which can be used as rocket fuel. And water is also essential for human life. Without it, astronauts would only survive a few days in space. In fact, when NASA's Genesis spacecraft flew by the asteroid near 2, it collected dust that later landed in the Utah desert, and scientists found that this sample contained more water than they expected. Given the right technology, asteroids could provide almost unlimited supplies of all these resources. That's why some experts think that asteroid mining is the key to sustaining human life beyond Earth. But it's not like we can just show up at an asteroid, hand-pick our favorite space rocks, and head home with a bag of galactic gold. First, we have to unearth the riches. And that's where robots come in. Autonomous mining vehicles would descend onto the surface of an asteroid, drilling and blasting into its crust to extract chunks of rock. Some mining companies have even proposed using giant space grapplers to snag passing asteroids and bring them down to a slower speed so they can be captured by Earth's gravity and brought back here for processing. And instead of mining companies shipping their goods to Earth, they could set up shop in space and build massive in-space processing plants. There, robots could load raw materials onto conveyor belts, then use drills, crushers, sifters, and other tools to process and refine them into metals, crystals, plastics, and more. And instead of relying on parts shipped from Earth, manufacturers could use 3D printers to create structures and tools using metal extracted directly from asteroids. But once refined resources are loaded up, who brings them back to Earth? Meet the cosmic transport. After being processed, materials would be loaded into reusable ships, hauled up to a space station in low Earth orbit where they could either be stored until we need them or sent on to their final destinations. And while all of this may sound like a bit of a hassle, asteroid mining could pay off big time. NASA believes that a ton of resources extracted in space could cost less than half as much as those mined here on Earth. And that means we wouldn't have to spend billions of dollars launching precious resources from Earth or flying astronauts on lengthy missions carrying all the supplies they need to survive. Instead, we could use locally sourced resources to sustain ourselves on other worlds. For example, producing methane for rocket fuel on Mars would enable round trips and enable explorers to stay longer without having to carry all the fuel they'd need for the journey with them. Asteroid mining could also allow us to build megastructures in space, like vast new space stations or giant solar power arrays to beam energy back down to Earth. And by identifying and mining certain kinds of asteroids along our planetary system, we could establish humanity's first interstellar stepping stones to Alpha Centauri or Europa or Titan. The possibilities are endless. Of course, there are challenges we have to overcome before we can start digging into these distant rocks. The first is the space environment. You know that harsh mistress. Asteroids are often exposed to extreme temperatures, high radiation, and microgravity, all of which can wreak havoc on electronics. Now we've engineered equipment to operate in tough conditions before, but dealing with the vacuum of space will be a whole new level of difficulty. Another challenge is economic viability. Is it cheaper to mine in space than on Earth? And will asteroid mining operations be profitable enough to keep investors happy? Finally, there's the question of who owns what. We don't currently have an international legal framework for asteroid mining, which could lead to conflicts if companies or countries start staking claims and bumping heads over potentially valuable chunks of space rock. Still, we're already seeing promising developments. In 2021, NASA awarded 17 companies contracts to develop the technology needed for commercial asteroid mining. And Japan's space agency successfully landed on an asteroid named Ryugu in 2019 and returned samples to Earth 2 years later. Meanwhile, private companies like Planetary Resources and Deep Space Industries have already staked their claims in the asteroid belt. So even though no one's launched a mining expedition to an asteroid yet, we're getting close. In the next decade or two, we should expect to see the first robotic prospectors touch down on their rocky targets, and the cosmic rush is officially on. If we're going to leave our cosmic backyard and become a multi-planetary species, we'll need vast amounts of resources, especially fuel. And asteroids have a lot to offer. But they're also just plain cool. The more we learn about asteroids, the more we discover about our solar system's history, including the events that sparked life here on Earth. And thank you for being a part of our space community. Your support makes it possible for us to bring the universe to everyone, everywhere. If you want to be involved in our mission, you can hit that like and subscribe button for all the latest updates. And if you want to help us reach even more people, you can help us spread the word about the importance of space and science by hitting the share button. Together, we can inspire the next generation of scientists and adventurers. So as always, keep looking up.